source and as a channel 1. My name is Emmanuel, and on this occasion I am going to show you how we can test this capacitor using only this digital multimeter to be able to attach the tips of the multimeter to the capacitor. We have equipped it with tweezers type tips, as we can forest well to verify if the capacitor is good. We need to charge it, that is, supply the energy, and then measure that energy, making it discharge for that which we will do. It will be first to download it because I don't know if it is charged or not. This was extracted from a card from a motherboard, so we need to first remove the power it has. How do we remove energy from a capacitor? This applies to any capacitor. I really take a flat screwdriver like this and just put some bridge between the tips like this. Look like this when I do this. What I am doing is that the two ends come into contact. When I do this, the capacitor is discharged and the capacitor is discharged there. How can we observe well once I have done that? Let's now check if it still has energy. What we do is we turn on the multimeter by giving it the little button here. Once the multimeter is on, let's take it into account, as if it were not configured. Let's put the selector so it's this. We are going to put it in the center, as it normally comes when you buy the multimeter. And we are going to put it where it says direct current voltage. For that we are going to rotate it counterclockwise. That is, in this sense, and we are going to put it on a voltage scale. These are the maximum values it measures in each one of the submodes. Within this main mode, we're going to put it at 20 volts. Why at 20 volts? Well, that's known based on the value that the capacitor has printed on the surface. This capacitor says that it has, let's move it a little closer, that it has 470 microfarads. That is the part of the unit for capacitors. And this is the voltage, 25 volts. Then it repeats it again, there says the brand. Here this white line indicates that this is the negative terminal, since this capacitor has negative polarity. It is this part. We are going to point out negative is, but on that line there is a little leg. That leg is the negative one, so therefore this leg would be the positive one. Well then, since there it says 25 volts, if we look at the capacitor, if we look at the digital multimeter, 20 volts no. Is it a good idea to put it? Because the power capacitor stores 25. So what are we going to do? In this case we are going to have to raise the scale. That is the voltage limit. We are going to raise it to 200 volts. There it is already at 200 volts chosen. As we can see, we are going to test it. So to test it we are going to take the negative, which is the color black. That is to say, it is the black tip coming from the multimeter, this one, and this one is the same. What happens is that, since the conductor is long, look, I'm going to raise it so that you can see. See, it's the same I do that I don't. I put everything so that you can see it, but it's the same. Like this one, the red is this one, and we're going to take the black one, that is. The color that indicates that it is the negative terminal, and we are going to place it on the negative part of the capacitor, that we already know what it is. Because of this white stripe with negative signs inside it. As we can see, then what I'm going to do is open this, and there it's ready. Now I'm going to take the positive and we'll see what the multimeter screen is. As we can see, it doesn't show me any value on the multimeter. Does it mean that the capacitor is discharged well? Once it's downloaded, what we do is the following. I'm going to take the negative terminal and put it there. At the negative terminal of the capacitor. Well, now we are going to change the configuration of the multimeter. We are going to use the internal battery of the multimeter to supply energy to the capacitor for storage. And then we are going to measure it to verify that the charging process is working and discharge of the capacitor. Well, for that you have to change this mode. You have to change the mode. So I'm going to turn it in the direction counterclockwise that I am going to enter the region of electrical resistance, which is this one that we see in green, which is where it ends. Here we are going to put it where it says 200, and we are going to charge the capacitor. How do we do it? I already have the negative terminal, the negative leg of the capacitor being held by the negative terminal of the multimeter. We're going to take the positive and we're going to hold it on the other leg. As I am doing, you saw that a value appeared on the screen. No value should appear. Right now, we are in the process of charging the capacitor. At this moment, this one, what it is telling me is that it is supplying energy. We are going to wait because we put it in electrical resistance mode at 200. On specifically what we do is that we are going to give it a time, at least not so much 1 minute or 1 minute or 30 seconds. 20 seconds is enough. It is only to check if it retains charge. If it retains charge, it's fine. Internal battery of the multimeter. It should be noted that it is 9 volts. Therefore, the multimeter is going to supply energy to the capacitor up to a maximum of 9 volts. It will not go beyond there because the multimeter does not have a voltage higher than that time. That's why the value we are going to go there is always going to be less than 9 volts. In this case, if we want to test it with a higher voltage, we look for a source. That I have a higher voltage and we can verify up to 20-25 volts. Well, it's already loaded, we assume. Now we have to check that part. What I'm going to do is just disconnect the part that is not whole. We are going to disconnect one of the legs, there, and leave the other there. We are going to change the mode of the multimeter again to how it was in the mode of voltage, I would say voltage and current. We rotate it clockwise, that is clockwise. The mode selector up to the 200 volt range, we could leave it at 20 volts because we know it's not going to store more than 9 volts, but we're going to leave it at 200 volts however we want. He's going to give me more or less the same number. So what are we going to do? And I'm going to put multimeter here in this terminal. What I'm going to do is hold him here, look at the multimeter screen, and there we can see the value as we can the valve. What have we got? We have 2.9 volts. It's going to go down. As time goes by, the value here will decrease. If by chance we want more details, it is very easy. Can we change the measuring mode, There is no problem. The multimeter allows it. Look at this. Look at her there. That is, we can do it. So as we can see, the energy from the capacitor will slowly be discharged. Because for the multimeter measuring the voltage, it is also consuming part of that voltage. But it consumes it minimally. which is why we see it go down so slowly. So look there, it's already going down a little faster, but we observe something as you can see on the screen. It's going down at a slow but constant frequency. Observe 5453551. Do you mean that what it shows me here is that the download is constant? That's telling me that the capacitor is in very good condition. That's what it's telling me. Does it mean that the capacitor discharges at the rate that it is consuming the energy that the capacitor already has stored, but it is discharging that energy in an orderly manner constantly? It means that the capacitor is doing its job very well. And already in this way, we have verified that this capacitor is in very good condition. This will really continue like this until it really reaches zero. And there it will be completely discharged, so as not to lengthen the video too much. We have already checked that the capacitor is charged. What we will do will be to discharge it by shorting the circuits. Look at what is going to happen. Look at this. With the multimeter on, I'm going to make a short, and look at what happens. Look at this. You saw how it went down to zero? Well, it remains. Look at this. It went up again. I just discharged the energy by making a short. When making a short, the internal energy of the capacitor is erased, eliminated, or rather transformed. And then that puts it back to zero for me again. Look, it went up again because it had a little bit left. Let's see now. Look, I will do it. I'll turn you on. We have already completely discharged the capacitor. So we have concluded. Now we are going to disconnect the tips here. We disconnect the one here, and we disconnect the other from here. And so we can test this capacitor. And most capacitors can be tested this way. There is certain information on the surface of the capacitor, such as the maximum temperature of 105 degrees, the brand, number of microfarads, voltages, polarity, etc. And so they leave any questions in the comments box. Can you subscribe to this channel? Can you also follow us on Facebook? Here on YouTube you can activate the bell for notifications to receive notifications of the latest videos that we publish every Saturday. By the way, you can share the video. Take good care and see you next time.
Subscribe to our channel SOSA NASA 1 in English and activate the notification bell to receive the notification every Saturday of new videos.